Welcome back to BarnesBasics, and in this video I want to do an ionic reaction, one which involves no exchange of electrons. And here is the word problem. Calcium hydroxide plus phosphoric acid yields calcium phosphate and water. In this equation, if we look on the periodic chart, we'll see that calcium is +2. It's in group 2A on the periodic chart, so it has an oxidation number of +2. It wants to give away 2 electrons. If we look on a polyatomic ion sheet, we'll find that hydroxide is -1. The whole ion wishes to gain 1 electron. We're supposed to mix this with phosphoric acid, which is H3PO4. How would you know that? You would have to just have a table of common acids and bases to draw from. This is another great thing to put on note cards. If you want to be the boss of chemistry, do that. It yields calcium phosphate. Calcium is +2, we just found out, and we know that phosphate is PO4 -3. Why do we know that? Because we have memorized our polyatomic ions. Water, we just straight up know that that is H2O. We also know that in its form it is neutral, so we can just go ahead and put a neutral sign on that one. So if you have not downloaded the charts for oxidation numbers, polyatomic ions, or oxidation number rules, then you should stop the video and download those and print them out so that you will be with me as I'm going through all of this. I have a video in BarnesBasics. It says something like balancing equations, ? Start here, ! So watch that video first. I think that would be a great place to start, but here we are in this video, and let's get this done. Calcium is +2 and hydroxide is -1, and so to balance these, we've got to have 2 of these hydroxides. So we would put a parentheses around the hydroxide, put a subscript 2 here. 2 times +1 makes +2, and that will cancel with I'm sorry, 2 times -1 is -2. That's a good trick. And that cancels with the +2. So this formula is balanced. Phosphoric acid, we've just memorized that. We just know that one is already balanced. We do know that phosphate is -3 and that hydrogens are usually +1. 3 times +1 is +3. So that cancels pretty nicely. Everything is pretty smooth there. In calcium phosphate, we're going to have to get a least common multiple of 2 and 3, which is 6. So what we need is 3 calciums and we need 2 phosphates. So let's put a parentheses here and make this official. 3 times +2 is +6. 2 times -3 is -6. That balances that formula, and we already have water as balanced. So as I look at this equation, I would probably just jump for the immediate solution here, and it may or may not work. Let's see what happens. So there's 1 calcium here, there's 3 here, so let's just go ahead and spring and put a 3 here and see where this leads us. We have 3 calciums here, and since we have some polyatomics that are remaining the same on both sides, let's see what happens if we kind of keep those 2 the same. We've got 2 phosphates here. What if we put a 2 here? What would happen? Let's see where this leads us. Is this groovy or is this a disaster? 3 calciums, 3 calciums. 2 phosphates, 2 phosphates. Well, in this case, we would love to be able to just say 3 times 2 makes 6 oxygens and put a 6 over here. What would happen if we did that? Would that be magic or not? I think it is magic. if we balanced the Oxygens next. 3 times 2 is 6. 6 oxygens here. We now have 6 times 2 is 12 hydrogens. 2 times 3 is 6 here, and 3 times 2 is 6 here. Kind of unbelievable, but I think that actually balances this equation. Kind of tricky, man. That's kind of advanced, I think. Kind of had to think about that one a little bit. So let's look back at it one more time. There are 3 calciums here, 3 calciums here. There are 3 times 2. There are 6 oxygens here, 6 oxygens there. 3 times 2 is 6 hydrogens. We got 2 times 3 is 6. That makes 12. 6 times 2 is 12. We were able to keep these phosphates together. 2 PO4s, 2 PO4s. This is good to go.